Good day, everyone. We are Group 7 from E1, and our experiment is all about sieving and liquid limit by Casagrande Apparatus. So, the liquid limit is the water content at which soil transitions from a liquid to a plastic form. A liquid limit test is used to determine the liquid limit of a soil sample. The Casagrande method or apparatus is a soil sample that will be passed through a number 40 test sieve, then mixed with distilled water to form a paste. A portion of the paste will then be placed in the liquid limit device or the Casagrande apparatus, level and parallel to the base. Record the number of blows or the revolutions and determine the moisture content as before. So the only objective for this experiment is to determine the liquid limit of the soil using the Casagrande apparatus. Good day, everyone. We are Group 7 and we are going to do the experiment number 8 entitled Sieving and Liquid Limit by Casagrande Apparatus. So the materials and equipment that will be used in this experiment are the following. We have the Casagrande Apparatus, the drying equipment, the number 40 sieve, the weighing balance. We have also the breathing tool. We have the moisture cans or containers. We have also the spatula for the experiment and also the soil.
So first we weigh the 3 containers for the oil.
Since in our experiment there is a procedure that we have to sieve the soil in a number 40 sieve. However, it is already provided with the sieve soil already, so we don't have to do that process, and we will be skipping that process, and we will be proceeding to the wet soil.
So this is the consistency of the paste. So I'm going to put it in the container.
So first we are gonna weigh the first sample with wet soil.
So now we are going to fill the Casagrande apparatus with the wet soil. We are going to fill about 3/4 of the cup.
Since we're done putting the wet soil on the Casagrande apparatus, we will then use a grooving tool to put a line in the middle.
So I'm going to count the blows. 1, 2. So we're done collecting the samples. So the next step is drying it and then dry oven.
Since we are done with our first sample, we will then proceed to the second sample, which is we'll be putting again the soil into a mixture bowl, so that we'll be proceeding with our second sample, and then we'll just repeat the process again. So now we are done mixing the second sample with water and soil. So this is the consistency. It is much more drier compared to the first sample of ours, and now we will be putting it in the second sample.
So we're gonna put the samples in the oven. Sample 1.
This is sample 2 and sample 3.
So the reference standard that we use for our experiment is the ASTM D4318, or also known as the standard test method for liquid limit, plastic limit, and plasticity index of soils. So we have here the results of our experiment. We only use one table or data sheet for this one. So as you can see, we have 8 collected data. So we have the number of blows, the mass of the container for each sample, the added water that we mix in our soil. We have the mass of container plus the wet soil, the mass of container plus the dry soil, and we have the mass of water, which can be solved using the mass 2 minus the mass 3. Next is the mass of the dried soil, which can be solved by subtracting mass 3 from mass 1. And lastly is the water content. So for this one, you can see the liquid limit chart of our experiment. So for the x-axis, we have the number of blows, and for the y-axis, we have the water content in percent. So in our first water content, which is 34.342%, we plotted our first point here under the 10 blows since it has 10 blows. Next would be for our second point, which is 20 blows, and that would result to a water content of 28.099%. And lastly, 27 blows with a water content of 24.815%. So through this, as you can see, there is an arrow pointing to the 25th blow, and that would be the result for our liquid limit, which is 25.5. So the x-axis, 25th blow aligning to the water content. So the liquid limit is being determined on the 25th blow, since theoretically this is the limiting moisture content at which the cohesive soil passes from liquid state to plastic state. So the liquid limit is important to determine since it can be used to predict the consolidation properties of soil while calculating the allowable bearing capacity and settlement of the foundation, and also it gives us information regarding the state consistency of the soil on site.